Oh man. Okay. All right. Hello, everyone. Welcome to the official Chicago Kotlin user group / Chicago Java user group with, of course, our Flutter friends and GDE and any other groups I missed, especially IIT students. So welcome, welcome. Yeah, no, thanks for being here. If I, for those that are online, I sincerely apologize. I thought I had this live the entire time, and that was not the case. But it should be live now. I am online.
It's live the entire time. That
so
was
I'm just
going to
mute my
It
phone.
should be live now.
Okay, great. Set up. Yeah. And welcome to my Kotlin Coroutine Mechanism workshop. It's kind of a workshop. It's also like a fun follow along. It is not totally necessary to like do this with a computer. I just thought it's nice to give an option for everyone. So not absolutely necessary. There's slides posted on SpeakerDeck if folks want to access these slides afterwards. Yeah, so before we get into the talk, we have a few announcements. So a little bit about Chicago Kotlin user group. We've been around for a while now. I think the group was running for a few years before even I went to my first one here. So these slides have been the same this whole time. Yeah, so we believe in being inclusive. CKUG is an inclusive and accessible group. I put in, that's why we mask up, but things are a little different now, but we did mask for a very long time. Be curious, ask questions, and avoid assumptions, and do everything you can to continue to grow trust, empathy, and friendship. Okay, so Chicago Kotlin user group loves seeing new speakers. In fact, a lot of our new speakers go on to give more and more talks. This is a really, really safe space to do it. So if you have even like a school project, an internal project, maybe you just like found like a cool library and you want to share about it. Some people do practice their conference talks here, but we've accepted every single talk and I haven't seen a bad one yet. So yeah, we would really love to see those those talks from everybody. Yeah, I'm sure there is a link in the YouTube, but if not, I'll be sure to add that and fix that later on. There are a few ways to keep connected with Chicago Kotlin user group right now. There is a Kotlin Links Slack that is somewhat free for everyone to use. I think there's just special instructions to sign up. It takes a day or two, but we're on the Chicago channel for that. And what's really cool about the Slack is if you're not on it, and you're trying to like learn Kotlin, if you get lost, you can just go on to whatever channel is relevant to you and you ask. It doesn't matter the hour, 20 people will jump in. It's crazy. This is how I learned Kotlin. So if you're not on Kotlin Slack and you want to learn Kotlin, this is like your lifeline. We also use Mastodon right now. It's been, I have to get the login stuff for that. I'm sure John has it. Like I said, it's been a personal mess, even managing my own social media, but the Kotlin Links Slack is probably the best one. And of course, Meetup is always a great avenue. But yeah, we're still getting situated there. So there's also Chicago Java user group. If you'd like to get connected with them, they also have a Slack and they have a LinkedIn group as well. So if you want to get connected with everyone that way. We also have, since the Pandy, we have a YouTube channel, and a lot of these talks were given during the time we were not meeting. However, I think we're going to kind of come back with like a hybrid model, because sometimes people still want to give talks, but they can't exactly come out here. So this is another thing that you could do. Instead of a live talk, you could do one online. It's not like recording or anything, but I do think it is a little bit more challenging sometimes. Like, it's personal preference, but it's fun either way. Just like check out the videos if you want to see what other talks are like. A lot of these folks, like, the talks are really great. Yeah. And finally, thanks to IIT Product Management Club for hosting us. So thank you so much. Yes. And I'd love to give the floor to you.
Yeah, hi everyone. So this is Nitin. I'm part of the IIT Product Management Club, and it's such a pleasure to have all of you. And thanks Amanda for
No, thank
conducting this
you.
workshop. Yeah, we host a lot of product management events, a lot of fireside chats. So last semester we had a fireside chat with a PM from AT&T, and on the 11th of Feb we are having a fireside chat with two people. They're a couple. They are both of them are product managers. So they used to work at Motorola. So we're going to have a fireside chat with them. If you are interested in that, uh, we can meet after the event so I can share the event details with you. But yeah, thanks again for coming. Thanks.
Thank you, Ethan. And yeah, okay. All right, without further ado, we'll just go ahead and get into the talk. So, welcome to Kotlin Coroutine Mechanisms. Let's see. For those that don't know, my name is Amanda Hinchman-Dominguez. I'm an Android developer primarily. I think I was a Kotlin GDE. I'm still figuring that one out. But regardless, I'm also a co-author for O'Reilly's Programming Android with Kotlin, Achieving Structured Concurrency with Coroutines. Yeah, that's me. I'm excited to share that this book actually got released in China earlier last year, I believe, and that's been kind of like a fun, exciting development. But Pierre and I, we wrote this book together, like half and half, and it was a really fun experience. And this quote here comes from the book, but this is like truly what our intention was for this book. So while coroutine concepts are important to master coroutines, you don't have to understand everything right now to get started and be productive. I will start with, so there's like some projects set up. If folks do want to follow along, all you need is an IntelliJ IDE. And if you already have it on there, you'll have to go to your run configurations and add -d kotlinx.coroutines.debug equals on to your VM options to be able to enable the ability for your logging to like show what number of coroutines is on there. I found out that this only works on IntelliJ IDEA, not Android Studio. However, there is a problematic way that you can kind of do something close-ish to that on Kotlin Coroutines test library. It's kind of messy to look at, but it's there, and that is all that appears to be available for Android Studio. Kind of a bummer because there's also a debugger GUI available on IntelliJ IDE that is awesome. Like I've been just staring at that so much because you get to see all the coroutines at once in every state that they're in at any point, like all 8 of them. It doesn't matter what the parent, like they have the whole hierarchy. That's really cool. So yeah, enough about the specifics of like the debugging, but I have some playground rules for this workshop. We're in the Rec League. It's not a big deal. A lot of the things that we'll be doing in this coroutine lab is not intended for anything like production code wise. However, even for folks that are like more senior, like we do these exercises like in a playful manner, and we do things we're not supposed to do so we can kind of like really understand what's going on with coroutines. And let's see, there's some additional setup. Looks like I already did add that VM option. I think I had a note for folks that are full first timers. How many people, like really quick, so I can make sure that I'm like doing what I need to do to share the right information to folks. How many folks are absolute first timers?
To what?
Coding. Let's start there. With oh, sorry. Okay, we do have a few. And then how many are first timers with Kotlin? Okay, we got a few. Okay, that's cool. That's cool. And then how many feel like comfortable, like familiar with coroutines / comfortable? Okay, it's like half and half. Like That works for me. That works for me. And I would say for this talk, because this is a meetup, please feel free to like shout out or like raise hands for questions. And what I'll do is I'll repeat the question back in case the microphone doesn't pick it up, and then I'll be sure to answer it because I feel like it's a lot more fun that way. So yeah, that would be really, I think that'd be pretty solid. Yeah, apparently that's microphone. I know, it's nice. I know.
Is that big thing a microphone?
Yes, this massive thing is a microphone. I'd love to see how it appears afterwards. So I don't know. We'll see. We'll have to see. I hope no one's been saying anything. Oh, we have a first timer on YouTube too, so that's really fun. Hi. Yeah, I'm really glad that folks are participating either way, and I am keeping an eye here as well. I'm going to actually charge my phone while we're at it. All right, so for this workshop, we have a few topics that we're going to go over. It's going to be split into coroutine behaviors for standard coroutine builders, and also swapping coroutine context. So before we get into all of that, we should start with what are coroutines? What are coroutines? All right, so we have, I'm sure like you can see right here, there's like some pseudocode there that's like code looking stuff. One of the hardest problems that coders have in their whole career, and this does not change, like there's like a great quote from one of the creators of Kotlin that's like, okay, there's like easy bugs, there's hard bugs, and then there's like concurrency bugs. Whole other level. Like concurrency is actually one of the hardest topics to learn. And the thing about coroutines and threads is what has existed primarily. I'm not going to give a history lesson because I did not prepare that. But it's something that is used in Java to manage multiple tasks running at once. So the interesting thing about concurrency is that it actually, there's like a whole lot of different versions of it. I'm going to go ahead and like just do some quick lines. You can get things like concurrency in a single thread, and that's like you have like all these tasks and work stuff, whatever. And then you also have concurrency where there's multiple threads. So it depends on, and this is just like units of work that you're doing. I have 2 + 3, doesn't matter what it is. So this is single threaded. And then this is multi-threaded. And even within this, you can get versions of concurrency here because there's different bits of work going on. And you can get concurrency here because you have multiple bits of work going on. You also have, what else? I think this is like a good thing to start with. We don't need to get into all of it. This is a good basic idea. However, the thing about threads, which is also available in Kotlin, for those that don't know, Kotlin is interoperable with Java. So they work together perfectly well. Either way, what they both use threads, and then of course Kotlin has coroutines, and we'll talk about that shortly. So we have all this threading stuff, but the thing is, threads are expensive. That's one bit. You can only run as many threads like as, I think there's like some relativity with how many CPU cores. You can only have so many because there's just blocks of memory. And you only have so much memory in your computers or your devices or whatever. So, one, threads are expensive. The other bit is that if a block of work kind of gets stuck here, nothing else is happening. You're just waiting. So we're working with kind of a timeline too. So blocking is kind of an issue. And another issue is like if we look at the parallel scene, it's actually really hard to coordinate what's going to happen where. You can't really control like the life cycle of a thread either. So a lot of that stuff becomes a little bit more haywire. So that's like the 5-minute version of a really hard advanced topic. But if you got that much, I think we're good to keep moving. So, and like I said, feel free to ask questions. I will definitely keep an eye on the YouTube chat as well for folks that are watching. Okay, so now we know a little bit about threads and some of the issues that they have. For those that like work with threads, can you raise your hand if you've been stuck on like threading problems before? Oh yeah, well, for those watching, nearly everyone in the room raised their hands. And of course, I'm sure folks who have been using coroutines, I've definitely sat for like at least 4 or 5 days on a single concurrency issue. It's possible in both. In fact, after you do this, you'll go off thinking, oh, I like understand it now. But in fact, it was one of those 4 days that had me going back to the basics to like really understand what was going on. So yeah, okay. Now for new timers, we're going to talk about coroutines. Coroutines is something that was created by Kotlin. Kotlin is, don't crucify me for saying this, but it's basically Java++. It's like the new language for Java. It's interoperable with Java. And there were a lot of solutions that were made to fix issues with the JVM. And on top of that, coroutines was something that was developed to help fix the problems associated with threading. And some of the cool things about coroutines is that they work in a different way. I really wish I didn't erase all that, but that's fine. Coroutines are really cool because we're going to look at a single thread. Coroutines can exist on a thread, and you could basically get these like different coroutines. We'll say this is one, you fire off another one, and you fire off another one. And here's the cool thing. We talked about this issue with blocking, but the difference between threading and coroutines is that a coroutine actually suspends. It's kind of like a dance. So if someone just like is running and then for whatever reason it suspends, it's paused. It's not blocked, it's paused. Some other coroutines like, oh good, the space is open, I'm gonna go ahead and keep going. So that's really the core differences between threading and coroutines. So that's kind of the way it just resumes. And then if this either gets suspended or it finishes, then coroutine 1 will resume the work. So give or take, that's kind of the core differences. I definitely should have, this is really great because I can actually add these slides if I do this talk again to make sure I include this stuff. So we're going to keep that there, or maybe I'll take a photo in case there's more questions later on. Yeah, okay, so now that we know all that, coroutine behaviors, we have run blocking, we have launch, and we have async. These are standard coroutine builders, and that's what you would use to like launch these like coroutines. These are like kind of the 3 mains that you would use. And the rules with them is that they always must be launched within some kind of coroutine or coroutine scope. Okay, so some other complicated things. I now see why this was not a beginning talk. All right, so there's, I believe, like such a thing as context within a thread. The idea is just like what's like the information that surrounds it. That's usually what the context pertains to. And likewise, coroutines also have a sense of context, but then there's this interesting thing where there's like a coroutine scope. This keeps track of a lot of information because it's possible. Remember how I said that you can only launch a coroutine from a coroutine? That means there's going to be some kind of like family hierarchy. So it's going to be a parent-child hierarchy. And a scope will keep track of that sort of thing. So in another scenario, maybe like we have coroutine 1, and within that work, coroutine 2 gets launched, and the scope knows that. So that's what all that is in case we start getting into this stuff and I don't explain it later. Okay. Really long intro, but now we're ready to do this code lab. All right, we're going to start with run blocking. Run blocking starts a new coroutine block and interrupts the current thread until completion. So this actually works in a similar manner to threading where the work is blocking, but it's still a coroutine. So we'll show you later on, but run blocking is able to get suspended. And if that is the case, it's possible to allow other coroutines to keep going. Regardless, run blocking, once you have that, a lot of the work on that thread gets stopped because essentially run blocking is hijacking the current thread that it's being launched from. Should not be used within a coroutine. Yeah, that's true. Generally speaking, especially in Android development, there's usually not a huge reason. I guess I'm not even thinking about services, but we're talking about main UI code especially. You should be primarily launching your run blocking really with like view model scope. So I think the rules here are a little bit different for server-side development. I will definitely check myself on that later on, but generally speaking, you're not going to be using this all over your code. That is the truth. Okay, so here's our first chunk of code. So you can see here, for those that are first-time programmers, function main is usually the thing that you see, especially in Kotlin. There's like a similar version in Java that you can use to just like run your first block of code. You press play and you see what the code does. And you see here we have the function main. The line one has a run blocking, so we can actually just run coroutines from the beginning. So now we have like task 1 and task 2. You see there's a delay. We talked about what delaying is responsible for basically suspending that's like the keyword for suspending the coroutine function. This is meant to simulate a background task. So let's say you run this task, but maybe you have something that's really complicated. You have like, download photos, but then you launch another like block of work that's like, yeah, but you need to like process all the pixels. Like that should be on its own child coroutine. And something like that could slow down the work quite a bit time-wise. So that's why we put in this delay. It's to like simulate that idea that there is a lot of work going on in the background. So now the coroutine suspended for whatever reason. So that's all that means. Okay, so we have run blocking, task 1, and then we have task 2, run blocking. I'm going to give folks like 15 seconds to think about what the order of the logging should come out in. So, no pressure or anything. And also, like, you'll see how this works after a little bit, and it'll be a lot easier to follow along. The first time's a little bit scary. The second time, you're like, okay, I think I get it now. So not too bad. Also, while folks are looking at that, I'm going to answer a question on YouTube. What's the best way to visualize a suspended function? Okay, I cannot even read. When a network request is being made, the function is still running, right? What part of it is suspended? Oh, okay. Jed IKV, sorry if I mispronounced that. Unfortunately, you're not in the classroom. There is a visual here, and that's a really good question. What I'm going to do is make sure that I post some of this and make it a little bit more verbal. But to reiterate again, the coroutines is a little bit different from threading in the sense that you're able to pause or suspend. So if you look at the code, this is kind of this idea of delay. And I will try to move away from the board. So if it is at all possible for you to like zoom in on this, we'll try it, but we'll keep going for now. All right, so I think I've given folks enough time, and we have the order of the logging going in exactly the same order that the code was written in. First, we have the main run blocking, we have the task run blocking, we have the task 1 complete, then task 2 run blocking, and then task 2 complete, and then the program ends. So this is not very useful code. We could have just done all that logging without all that launching. So that's cool. That's cool. But now we're going to get into launch. Launch is another standard coroutine builder. And this will start a new coroutine, and it will create a job instance. Actually, fun facts. Jobs, like all three builders, like you can save them like how we saved it to like val task 1, val task 2. All of these types are saved to a job. So it's not just launch. It does not return, in this case, for launch, it does not return a result. It just returns like a reference to the job itself. And the job is kind of like related to like the life cycle of the coroutine, because as you can see, we're running on a timeline of some sort, so we need some kind of life cycle to keep track of it. And with a job, it's able to cancel itself, and you're able to use the keyword join to force the current thread to wait for the completion of the job, because a launch quite literally means like fire and forget. Just fire it off and then keep going. All right, now we're going to look at the code that we had from before. And what's different now is that we took task 1 and task 2 that we already put in, and now we're wrapping it into a launch, which is saved to job, which is a job type. I'm going to give you all about 20 seconds to guess what's going to happen. That code that's kind of like faded, that's like from the last run, in case you like kind of forgot what the last run was. So you just got to think about how would this show up differently. And remember, this is a fire and forget mechanism. Okay, 5 more seconds and I'll show the results. All right, these are the results. We have main run blocking start job, then the program ends, and then the job is launched, and then everything else happens the way it should, I guess. So yeah, what happened here? This is kind of what I'm talking about with this like fire and forget mechanism. What is happening here is when we call that launch initially, the program has acknowledged, yes, this coroutine has in fact been created. But what's also really interesting is if you run this on like, I think Kotlin playgrounds or even like other IDEs, it is possible to get different results. It really depends on the environment and the compiler. So that's also really fun, but we're running off IntelliJ IDE for this one. So yeah, what happens is we've launched the task, but then it just kind of keeps going, and then the program's like, oh wait, yeah, we have this like coroutine launch, and so here is where this is kind of like where that weirdness is, right? So we're gonna go through a playback to like see what happens step by step. I clicked it twice. So we start with the first one, main run blocking, then we have start job, then we have program ends. We actually like technically ran over val job launch, but nothing inside yet. Okay, now the program's like, oh yeah, we got some stuff here that we got to finish. And actually, I think there's like one version of an IDE where just none of this even prints. So that's really fun too. Yeah, so we'll keep going. Then we go in through to our run blocking, and this is the same exact behavior that we're kind of going through in the last exercise. And the fun thing is here, yes, like it is suspending, but because we're working with 2 run blocking mechanisms, all it does is just pause for like a second. So 1000 means like it's 1000 milliliters, so that's 1 second. So that's very useless. that's what we're doing. Then we do this, and then we do this, and then we pause again for another second. Also very useless, not great. This is like stuff that really starts eating up your time and work, and you start complaining like, why is your stuff slow? So yeah, now we're done. So really weird stuff. But that's where the job.join comes into play, because now we're forcing the program to say, don't do anything else. until this coroutine has been finished. So if we press run again, what do you think is going to happen? I'm going to give you another like 15, 20 seconds to try to see how this program would like change in the logging. Also, experienced folks, you can call me out anywhere too.
The logging is already up.
Yeah.
Shit. Okay, well, never mind. Thanks. All right, well, that is the answer, man. All right, I'll make note of that. But let's run through the playback one by one. Yeah. All right, we have main run blocking. Then remember from last time, we have this fire and forget. So the coroutine has indeed been created, but hasn't started running yet. So we have start job. Now we go to job.join. Probably would have made sense to add the yellow there, but that is where we go. And after that, that's when we go into the coroutine to finish the work. So we have a job launched. Then we go into run blocking. Then we pause, which is still not great. Not 100. Then we go down and we finish the work. Then we go into task 2. We delay again, so the whole program just pauses. Not great. Another fun thing, like this is kind of like a fun Easter egg too. You see how there's like all these coroutine counts too. There's this thing called main that is indicative of what thread we are currently on. So all of this is currently on the main thread, and in real life, if this was production code that we would never use, your whole program would be stopped. Like it's so. We go into task 2 completes. Then we go into program ends. So all is right with the worlds. Okay. Let's see what we do next. Oh, now we're going to add more to this picture. So we're kind of familiar with what launch does now. What would happen if we took task 1, which is run blocking, and we made that a launch? Please tell. Okay, that's like the old result, so no one can cheat this time. Okay. All right, so we have, is that even the right slide? I'm worried this is not, but I'm gonna read it out and make sure this is correct. All right, so we start with run blocking, should be start job. Then we have job launched. Then we get into task 1. Oh, you know what? Yep, that's correct. You're right, this one's correct. So yeah, I'm telling you, all the text starts looking the same after a while. Yes. Task 1, then we hit delay, and then there's task 2. Because remember this idea with the suspended function? We called suspend. And now because we're working with a launch, we're allowing other work to complete while it's fake. And then we just let this keep going until it gets stuck or it finishes itself. All right, so we're going to go through. This is kind of like the main change from like the last prompts. We're going to go through the playback. So we have main run blocking. We have the start job. We go to job.join. We get into the job. We have our job launched. We have task 1. Now, when we hit delay, we actually suspend the call there, and we allow task 2 to start running. Now, we hit delay here, and this is the bit that's interesting because I really thought, oh, like, shouldn't it just, keep going? Like, shouldn't it not matter? But I think I ran this a few times, and I'm pretty sure that it kept giving me this result every time. So I don't know. I swear it was different at one other point, but that appears that the suspension allowed the launch to continue. And we get into task 2 complete, because what happened in the previous slide, because we're like, oh, we're done now. Like, what else is left? We get into task 2, and now we finish task 2, so we can go to program ends. Okay. Everyone's still, yeah.
Could it also be possible that the log for task 1 doesn't come before the log for task 2 in the same way that the outer launch stop launch log line in the last example didn't happen until after the
Yeah, right. Like, you would think that. That is some, by logic's sake, yeah, that would be something that would occur. I don't know. It's just so weird, because this is what was showing up on my current version. So I don't know if this is behavior that's ever changed. And yeah, I mean, with my own thoughts, I was like, yeah, I don't know. Maybe part of it, I feel like the way coroutines has always worked. This is a really good question. Let's put a book note on this one, and I'd love to actually answer this in detail. Yeah.
There's multiple possibilities.
There are multiple possibilities, yes. And it is also, like I said, possible for outputs to run differently depending on what you have. This is why concurrency sucks. So.
I think it all depends on dispatch you're running on, how it's implemented.
Oh,
right.
that's
Like an Android's main thread dispatcher is going to have a message queue internally.
That's true.
What is the main thread here is going to behave differently on just running on a console application and whatnot.
Oh my God. Yes.
IO thread pools, like multiple threads.
That too. Yeah, that's true. For those that didn't hear, there was some discussion on how it also depends on the environment and the system too. So for example, Android runs on a message queue, and there's also like your dispatchers are mapped to like different, like whatever that system offers, it's mapped to different things. So if you go to like dispatchers documentation, like I think it tells you what the specifics are, but it never really discusses how it looks different. I think this would be a really fun thing to go into as like a whole other talk. Yeah, really great question though. Thank you. That was. It's making my brain hurt. Okay, cool. So we got into this, and let's see what the next scenario is. Yes, of course. We got to change our other run blocking to another launch. So I'm going to give everyone another 15, 20 seconds to try to see what would look different with this one. And for clarification and specification, all these were done on IntelliJ IDE. Like, that's it. Like, in case folks want to run this on other things and they're getting different stuff, please definitely comment, like, in YouTube later on. It'd be really fun to investigate and explore.
It's the same. Why?
The same what?
I thought we just did this.
I think last time we made task 1 a launch, but this time we're making task 2 also a launch. So now everything in here is a launch.
But it's run
Oh, you're right. I apologize. You know what? There was a reason for all this color coding. What we're doing is we're changing that to launch, and then we're adding another launch onto it. This one is a solid 15 seconds because I think we know kind of what the rules are now. And yeah, thank you for that. I'm also not sure if I have a playback for this one, but we can definitely talk through it. Okay, so the answer. This is what looks different. Wow, that does not look green on there. The coloring is so different on the screen versus what's on the computer. Yeah, so we have task 1. We hit the delay. Then we're like, oh, good. Task 2 is ready to go. So we're going to fire that off. But then that hits a delay. And then we run task 3. But we hit that delay too. So we go into the first coroutine that was waiting for their turn in line. And that's going to be task 1. They said we still have work to do. So they go to task 1 complete, and we go to task 2 complete because task 1 finishes. Then the next coroutine's like, oh, I'm the next one in line, so I'm ready to keep going. Something that is good to make note of is sometimes when you launch like child coroutines in particular, you're able to run like multiple pieces of work in parallel, and sometimes you don't always get the right ordering. So this is like really basic stuff, and also even like running a debugger can slightly alter the behavior a little bit, because the whole thing is that we can never truly control like the life cycle of either a thread or a coroutine, but coroutines are easier because it's kind of like a creek, and you can like bend the way that it runs its currents. So it's a little bit easier, but you can't, even from program to program, debugging, not debugging environments, the behavior is a little bit altered. So this is why a lot of us end up playing with this stuff over time. Okay, so now that we're kind of familiar with launch, what would happen if we took task 1 and task 2 and we called join? I'm going to give 15 seconds on this one too. Yes, for sure, yeah.
For example, like if the delay for the task 1 is 2 seconds and the task 2 and task 3 is just 1 second,
Oh,
then we are running it normally. So in that case, what would be the output?
that's such a good question. So
for that, we would be expecting the task 2,
yeah,
then task 3, and last task 1 would be what?
yeah. Did you have the answer?
I was just gonna say the broader
Yeah.
concept to consider is that in a real world scenario, if these represented separate pieces of work, there would be no guarantee on the ordering in which they finish. So
Yes.
we're using the same delay, so there's a neat kind of like structure to this for the sake of example. But
Yeah.
to answer your question, you shouldn't count on there being like a specific order that it happens in unless you're using those joins.
That part. Yeah, because you can't theoretically, right? That's the whole bit. Theoretically, this should happen, but I don't know. But it's something you shouldn't always count on unless the joins come into play. That's when you can actually consider the timing. So that is, it's really interesting too, because in a lot of production code that I work with, although to be fair, sometimes like, your teams are focused on different things. Like we don't work with a lot of joins ever. We often work with, actually we don't work with async that much either. But you know what? That's why coroutines are hard. They're easy to start with, and then it's hard to have those conversations with folks sometimes. So it's sometimes a touchy topic. So yeah, another 10 seconds, and I'm gonna hit play. All right. Okay, this is what we have now. So in IntelliJ IDE, when we run task 1 and task 2, we ask it to join. So the interesting thing is task 1 and task 2 launch, they kind of have that similar behavior from before, especially because we told the program to stop everything it's doing. We got to wait for the stuff. And then task 3 continues, and it looks like it's in order because there was no other work to complete. Okay, we do have a playback for this one. We start job, and we go to job launched because we called job.join. So now we're going in, and we're not proceeding until the work within this is complete. So we have job.launch. Then we go into the first task. Then we hit delay. Then we go to task 2. We hit delay there. And normally, before that, we would have gone to task 3 before. But because we told the program, nope, actually, we're going to wait on this other stuff to finish first, then we go immediately back to task 1. Then we go to task 2 because task 1 finished, nothing else to do. Then coroutine, whatever, says, okay, oh yeah, I'm in line. I guess it's my turn to go. Then we go to task 3. Task, of course, the delay. We can't forget the delay. And we go to task 3 complete. the program ends because all the work for job has finally finished. Okay. So I think how are folks like following along? Is it okay? This is awesome. Okay, I'm really stoked. Like this is why does the text look like that? That's crazy. Yeah.
Share an observation on the last slide.
Yeah.
I think it's important to consider like all of this is running on the main thread.
Yes.
And, like a single thread can only ever execute one piece of work at a time, like one.
Yeah.
Code. And so all this like reordering, every time we hit a delay or it suspends, that basically says like
the whole.
I'm not using this thread right now. Somebody else can use it, so it's able to go into other bits. And so all of the launches are unblocking. All of these builder functions, they're just adding units of work to a job queue, and then the delays are suspended.
Yeah.
And so they're saying, I'm not using the thread right now. Anybody else can. And the join is really just saying, like, wait for that unit of work to finish.
Yeah.
To be completely done. So it's like really just a job queue.
Yeah, that is what this is.
Add all the threading stuff in that we haven't got to.
Wouldn't it be fun to present this at work as like an idea and see if they toss you off a cliff? It's a fun idea. It really is. But yeah, that's the other thing too, because we actually haven't even gotten into background threads. We never even entered that realm yet, because that's where things start. You're given the ability to run things on multiple background threads, and that's where it's really possible to start getting that parallelism. And the other part, I don't know if this is completely true or not, but personally, I haven't seen anyone trying to dictate what thread they're running on. You just kind of let coroutines do its work and it'll figure it out for you. Now, there is some like scope of range around that, but we will get into that later in the talk. So for those on YouTube that did not hear, because I have no idea how good this microphone is, Ryan made some really, really good observations, primarily that because we're working on all these coroutines are running on the main thread, it's acting as units of work on the main thread, and it's basically like a job queue. That's the current functionality of this code. But it is a really fun exercise to go through, and I think it's a really, really great introduction before we start trying to do multiple things at once. Like it gets a lot from there. So all right, we're moving to, I believe, our final coroutine builder, and that is our async builder. This actually gives the ability to kind of do this async and await pattern. And you have an await. That's what that really gross text is supposed to say, await. It's just, I don't know what that is. But yes, the await key, I can't even look at it. Like, the await keyword that's the keyword that you use in a similar way to join, but its functionality is slightly different. And really the main difference is that before we talked about, first we know that all coroutine builders are saved to a job type. We know that launch does not give a result, but async actually does. That's why in here I have this this is like pseudocode that I probably should not, it's like not even correct, like I think different crowds. So I'll be sure to like kind of make it more correct next time, so folks are more familiar with like what the code should look like. But yes, async is assigned to a deferred type, and the T is related to some kind of generic type. You can put any kind of type in it. So whatever you put in that is what you're getting back. And when you call await, that is when you actually receive the result. We don't know when, it's just whenever it finishes, but we get it back when we call await. Yes.
Similar to like in the world of whether you're like void or return types, right? So like launch is one shot of like the void function.
Yeah.
And the sync is like you want to return something.
Yes.
They call it already.
I think I think that's a great way to think about it. I feel like that makes sense in my head, and so I'm gonna repeat it one more time for the folks up here, because again, I have no idea if the microphone works well or not. So for those that did not hear, A great way to think about the difference between launch and async in the Java world is like in the Java world, you run off some like function that like returns a void, which means there is no return. There's nothing to return. It just fires it off, and then whatever happens, happens. And then async is different because like the metaphor here is like you have the function that you write, and then you have a return type, deferred T, whatever you got, T, it would be T. So it runs that call stack, and then whenever that finishes, you return that type. So that's a good way to think about it for those that are more Java oriented. Okay, so there's also like a fun dictionary. Deferment is to put off an action or event for a later time to postpone. I thought that's kind of a weird one for the way that we think about this, especially because it's like, well, it's like technically running. It's just we're not going to get it immediately. So I don't know if that's why I got confused by the word. I'm always so literal with stuff, but whatever, fine. Like we'll just think about it like this. And that's the that makes more sense, but you're right. Yes, it is deferring the getting of the result. Silly. It's kind of silly, but yeah, you're right. That does make sense. Okay, now that we have an explanation of the async, we're going to play with that. We're going to change task 2 to be, instead of a launch, we're going to have an await. It looks like I moved it down too, so I'm sorry. I threw a curveball in there. I think I just really wanted to test you, like, yeah, so we have val2, which is now a deferred type, and we're returning a string type. And one small difference that you might have noticed is like, how in all the other tasks 1 complete, for example, that's wrapped around a log, but there is no log for task 2 because we're actually, like, that's the thing we're going to get back. So we're not logging it yet until we go down to log task2.await. So that's where we put that in. But we get task 2 complete. Like, so you could, if you had a deferred int, I could put in 1 or 2. And then if I logged it there, it would just be like printed out to 1 later on. I'm going to give another like 5-10 seconds to guess what the output is going to be, and then we'll see what the result is. All right. There's a lot in here. Okay, we have task 1. We have task 1 runs, then it hits the delay. Task 2. And of course we have that launch, so we have to wait for task 1 to finish before we do anything else. That makes sense? We have task 2. Now this is where it gets kind of weird because technically in task 2 it's still delayed. Apparently we created task 3 launch, but we did not start running that work yet because then the code goes down to the green line. Oop, that was too early. Task 2 status. And then apparently there was some work already going on in the background here because we got the work here. Actually, at that point, task 2 was suspended. I'm going to see if I can try to point this stuff out. I think it'll be a little bit tough because I think that was another... I knew I was like, I wanted to draw something else. I couldn't remember what, because it'd be really cool to kind of see the representations of the state of every single one. What I'm going to do is take a photo of this and we're going to make a new diagram. Whoop. Maybe we'll do a selfie too later on. Okay. I'm going to do 2 and 1. We're going to run the playback. Okay, we're starting with run blocking. That is technically the first coroutine, right? It's our big old main. That's not great, but I'll just say number 1, run blocking. Then we have job launch. So now we have a job inside of that. That's coroutine number 2. That's job. Then we get into the work there, and now it's paused. So now we're suspended. Okay, we start task 2. So we've launched another one. Whoops, this was the wrong interpretation. So now we have task 2, and that's an await, right? So it's currently running. Then we hit the delay, and now that one's suspended. So we keep moving down the work, and it says wait, but we actually have to finish that. So this is currently suspended. This one is back live running, and we go back to finish the work here. So now this one is done. Okay, and now let's see. It looks like I don't know if that's actually, that might be the one where it was like, yep, there it is. There's that incorrect one. I knew it. You know what the problem was? I was doing this in a bar. So don't pay attention to that last one. This did not happen yet. Actually, we probably don't have access quite to that one, because even the fun part is like, now I'm mad at myself because this is even, just all right. Well, the printout is correct. The playback is not correct, according to IntelliJ IDE, because we go back to this status. We're now saying that this is running live. And here's the fun thing. We go to like task 3 launch, and that's only like created. I would have expected, to be honest, that we started on task 2 and then that delayed, and then I don't know. So now you got me really thinking about like shouldn't it have now I'm thinking a lot more in that way. It's so easy to just go from that. So we have task 3 that has been created, but what I'm going to guess happened in this like job queue instance is that actually the work probably did finish for task 2 in the backgrounds, because it's still like, just because it's suspended, well, when it's suspended, but you can get that work later on. You're just not going to know when until, because it's possible for task 2 to actually complete, but you wait to get the result there. That's the part that's like getting me really messed up. So now I feel like I have to like go back and rework this one to actually give a much more accurate explanation. Because the thing about deferred, yeah.
You could put another log line under the delay in task 2 before the return, and that would give you like a little bit better sense of when the work
Yeah,
is
you're right. I should do that. How do I don't know. Sorry, this is like a cheat for myself, but maybe I'll just, hey, this is the fun part about a meetup. Add task 2 log for clarity. Yeah, because this is like finally the one, just don't you do that.
Basically just keep the pattern the same as you have been.
Yeah.
Log before and after the delay, just add the return string underneath that second log within the task. At least then you get a sense within the call stack output when the task 2 finishes, even though you're not actually going to print out the return value yet.
Yeah, okay. You're right. That could be something that you're right. I see what you're saying now.
Because you have no indicator of
when the delay actually or when it resumes. Yeah, you're right. That would be another good one. Yeah.
Now, if you remove the delay from task 2, will you still have the same output?
Oh, that's such a good question.
Since the await is the results.
Yeah.
I would think so.
Although,
like it runs through, but it doesn't give it to you.
Also say complete proposal.
For task 1 and task 2 would be complete?
And both status before and after wait, would that both be completes or not?
Yeah, you would think so with the delay.
Without a delay.
And the other problem is that
we're that await for it to be think it would once again depend on like dispatch.
Yes.
Yeah, perhaps you.
Because actually I did get different results specifically on this
Okay.
on this specific example, and it also depends on whether you're running it on the background or the main thread. And this is such a good point because I need to make some notes for myself. Like there's a lot of questions that we could definitely answer in a much clearer example here. But yes, I feel like to answer your question, the scenario that you described where it's like, yeah, the work was technically already complete, it did happen for me when I put it on a background thread. But I think this is what it gave me on the main thread. So now I feel like I have a whole other talk I could write in itself. Like my mind's being blown. But yes, like, because I was looking at it, I was like, what the hell is this? And I'm like just trying to get the original point that I was getting. And now this is making way more sense. Like, because you start working on this late nights and you start ignoring like why is it a little bit different? And so yeah, it is possible that it could be running differently depending on the dispatch that you're on too, as Fabio mentioned a little bit earlier, which is like yet another factor of how concurrency can run differently. And that's why we do all this little stuff. It's just really crazy. So on the main thread, I think that's like maybe the main part. Like on the main thread, this is probably the main difference with these like subtle differences. So yeah, we have the task 2, the task 1, and then according to work being living on the main thread, then you have launch task 3. And because we kind of finished everything else, there's no other work to go. So it just finishes and then the program ends. Yes.
On the log, so deferred active means you haven't called the wait yet, completed means you have called the wait.
Yes, that's right. Yeah. Well, I will say, you know what? That's such a good point because
Yeah, that's also the test.
Okay, because like if you do log test to await 5 times in a row, it's not going to wait 5 seconds. It's just going to return over and over and over again.
Yeah. So yes,
I want to.
the deferred has an internal state.
Yes.
Where it keeps track of itself when it's running, completed, or canceled. Right?
Yeah.
Yeah.
So it'll just return whatever.
Yeah. So if you do the wait again, it will just want to debate it because it knows it's already done stuff.
Yeah.
It's not,
I wanna-
it's not tied to the job then. So it's just.
It is tied to the job, and I want to fix my answer. I said yes, but I meant no because remember how we were kind of talking about like, hey, like what if this run a little bit differently? With Ryan's question a little bit earlier, and then I mentioned, oh yes, actually on a background thread versus because that other example that I was talking about where I said that I was getting the completion like earlier and it really annoyed me, and I was like, no, that's not what I'm trying to do right now, and I ignored that. So in that scenario, it ran the same except deferred active was deferred complete. So the work had already completed before we called await in the background instance.
So completed refers to like the work in the coroutine.
Yes.
Okay.
Yeah. And then to me, await is just, you just get it whenever. And sometimes like the bit about await is with the way that I understand it currently, this is not good. I don't know, maybe, yeah. Let's say that this is how much time it takes for async to run and you call await here, then everything's gonna stop and you call it here, like it's not ready yet. Then we just kind of have, it works the same as join at that point. There's like a little bit of lag. So that is a possibility. But if we had already completed the work, this timeline was not a good thing. But if we had already completed the work, like it was done a while ago, yeah, this was not the good visual for it. But you get what I mean. We had to wait some time before, but it is also possible for it to finish the work, and then we call it. It was like, oh yeah, we were done a while ago. We've just been holding it for you, and yeah, then you can grab it from like that generic value. So these two scenarios are possible. So that's what makes this so hard. Yeah.
Maybe just for like other purposes of representation in the future, like
Yeah.
So task 2 complete as a log, sorry, as the output of the await, I would put the log line task 2 complete back under the delay, and then output like task 2 accessed or reported or fetched or something like that.
Oh.
Your actual as a result. of your
Oh, I
wait
see
log.
what you're saying. So like just have something
Yeah.
like first wrap it in the log, task 2 complete, the work's done, and then return
Yeah.
task 2 access.
That way it's clear like how long the actual work took versus
Yeah.
the next value.
Oh yeah. No, yeah, that would be great because now we would get 2 more bits and that would be a lot clearer. Like we would really know. And maybe we can do that at the end of this talk. We could just try to run it and see what happens. So I think that's what we'll do. Let me just write up the whole thing because if I don't, I'm gonna forget the whole thing. So task 2 equals async. We launch this, we have a log here, then we have the delay, and then that's for me to remember to like try this out in a little bit because I think this would give us like a slightly clearer answer. Okay, whoops. Okay, all right. I don't know. Let's just try it now. Like we're at a good point, so I feel like we can. All right, let's go to IntelliJ IDE. Oh, I hope I have something on here. I was working on something for something else, but that's okay. It's the fun preview. I'm working on an online course, so that's fun. I finally signed a contract for that, so that's really exciting. Let's go here. You can't really read the screen, and that is terrible. I'll go to settings. I'm gonna fix it. I mean, I don't even think I can read it myself on this. Like, this computer is not. In fact, this is. How do I get there again?
So if you go to view,
Yeah. Oh, good call. Don't do this to me right now. It's doing that thing, you know, the. Oh, you're right. Oh, now there's so many bugs with this new one. Okay. All right. I should have gone to like the main class first, but that's all right. That's it. Let's just copy paste that code. Where did it go? Oh, yeah. All right. We're going to take all this code. We're going to go to IntelliJ IDE. Ignore all this other stuff. I was just playing with like things that would actually choke up the code a little bit. We'll keep that log. All right. Import. Is that all of it? And then we're going to do that thing that we were talking about, which is log it here. See if we get a slightly different answer. Actually, I guess I could show you like the coroutine debugger on here too. It's just so cool. Like,
Can we just step through the debugger?
yeah. Yeah, we can. We can. All right. My computer might wig out a little bit because it can't handle like so many. It's completely terrible. Yeah, we can. So what I'm going to do is probably put a stop at every delay. And then I just realized that YouTube cannot see what we're doing. So I'm just going to fix that for them. Sorry about that. Print, extra camera, share screen. I guess entire screen works for now. Nice. I can definitely edit that one screen out. Okay. Can folks see that screen now? I think there's just lag on my YouTube. So, oh yeah, you can. Cool. So you can see it on YouTube now. Cool. All right, so if folks didn't hear, we're trying a new experiment because we were talking about how it's possible to call async await, but the work's not actually done. And then there's another scenario where, in that scenario where it's not actually done, we might have to like wait for real on it. And then there's another scenario where it's already done. And in that case, there's not going to be like any additional suspending. So we're also going to show you in this talk how to pull up the coroutine debugger. I think this should be good. I like to do, oh no. I don't know how to work with presentation mode. Okay, just stop pressing that. Go on the number screen. Don't actually press the thing. We don't need that one, but we have a wait. I want to make sure that we actually have these other bits too. And then also the caveat here is the fact that we might get a different result even debugging. So that's another fun bit. But that's a nicer thing about running everything on main. It is more likely to be true. Okay, so another bit, I want to make sure that I have, oh, it's just horrendously slow. That's okay, I'll just kill this. This poor computer is probably like, why are you doing this to me? Just look how slow it is. Okay, runnable, why did it, oh, no, okay. It's because I was doing other work that just leave it alone, you know, just, okay. That's what happens when you do stuff in the middle of the night. Okay, we're gonna try it again. We have all these debug points. I'm going to hit run debug, and we're gonna wait for the first bit to go. Okay, nice. So here is how you do it in IntelliJ IDE. Okay, now we have this console, and I'm so sad this is not available in Android Studio because this was a real game changer for me. Is it truly that slow? Now, why did it do that? Wow. Wow, yeah, that I can't believe it let me do that. That's so crazy. Okay. And now the formatting doesn't even look right either, but I don't care. You know, just I wish here, can I at least Option Shift L?
Or just shift format document.
Actions. Not quite. I think what I'm going to try and do is get this to just sit on the side, you know, just left top, left bottom, bottom right, maybe. It doesn't even do that. I think this new version is just not great. This new IntelliJ version is a little buggy, but that's fine. I don't even know, is it even running? It sounds like it's running. It finished. Oh, right, because, right. Okay, here we go. We have, that's the other part. I was just mastodoning about this the other day. Like, why do I have to click this every time? That's really annoying. So this is what I was talking about before with the running and the creative. Is it okay if we turn off the light just for a second so we can see this a little bit better? Oh yeah, of course. Settings. And this is like a good tip for folks. If you know you're going to do a demo, definitely get this set up because as you can see, not all of these are created the same. But now we can see this. Oh no. Let me just do this again and see if that fixes that. I have to do it again. This is so, okay, we can read it now. Okay, so this is really cool. You can, sorry, it's a little bit small. We just have so many tasks now. But now we're kind of sitting in the main one, right? So We have currently coroutine 1 and coroutine 2. Something fun that I want to talk about, because we're about to talk about this in the next part, is this idea of like coroutine dispatchers. You can actually put in an argument where launch is. So like it actually does have the ability to, you can put in like jobs and stuff like that. Honestly, that could be a whole other talk. It gets really crazy. We're only going to stick to context today because that's all we got time for, really. But something you should notice here is that because we did not put in any arguments, like you generally don't need to put in jobs as an argument, because this idea where you just do the launch with like nothing else, unless you put in a context, like you have the scope that you're respecting. And if you do anything like put in a job, you're actually breaking the parent-child hierarchy. So it's not necessary to include a job if you just launch within. It's going to understand what the parent-child hierarchy is. So we actually see that right now. We have coroutine 1. And then within, there's a created coroutine 2, which is presumably task 1. We should see nothing yet. It just looks like it created it, and that was kind of it. There's a job.join. Oh, sorry, I meant this one right here because I forgot to put in the launch. We should have seen that. So we're debugging. All right. We're going to start job, then we're going to job.join, and this thing just will not remember that I selected that several times already. And it looks like, let's see, we're in rem blocking, we're in job, we're now at task join.1. It's so hard to like, you know, there's a little bit of they got to work out some kinks with this. Like, how do I even get back? Okay, so we have task1.join. Where do we go next? Because we should have seen all this other stuff. That is so weird. I feel insane. Okay, we go to task 2. We go to task 1 completes because task 2 delayed. And you can see here that coroutine, coroutine 1 is the blocking coroutine that's currently suspended. That is the parent coroutine. This is technically coroutine 2 right here. And that is running as active right now. It's currently completing the work. Now we have, well, we finished, so I guess we go back down here, and this is for async, remember. So actually, I think this answers your question earlier, Ryan. It looks like the work continues, so it's like this is indeed running, and we finished the work there. So it probably means that indeed it ran exactly the way we thought it did in the past. That's a relief, because I was that was a relief because I was starting to get messed up in my head for a second. I probably have to go back to some of these slides and make sure that they are super correct. So works the way we thought it should. It went through, and we have our answer. It's just saved to the variable. We're just not doing anything with it. That's all. Okay. Now we go to task status 2, and that is where we print the status. Do you think it's going to give it to us now? Or can you give it to me now? Deferred, it's now noted as completed. Oh, this was the other thing too, the difference between the debugging versus the not debugging too. Because I think if you run it, like it'll come out differently too. So we'll have to do that too, like in the ends. And then of course there's task 3. That is so, like, I'm wondering if, I don't know, like maybe it's the fact that I'm like choking up this computer too, because you know how Gradle kind of like, this computer is like, it came from Groupon.
Is it just the debug process that's allowing it to go through the full delay before it even goes to the next step?
Yeah, and in fact, it acts even different now just because of all the stuff that I'm putting in and the fact that I'm running the camera. I'm running Spotify. Like I have like a bunch of Chrome things on. Like I think it's like changed even now. So now if we like run this whole thing without actually, sorry about the formatting. Let's see if did it run it? I can't tell. Okay, and here it's completed too. I feel crazy. You know what? I swear if I go home, like I'm gonna run that and it's gonna come out differently because I ran this like 3 separate. uh,
Maybe that's correct if the definition of complete is that the work was completed.
Yeah.
Not that it was not that weight was called.
You can test that by increasing the delay async.
the delay in the async. Wait.
Or increasing delay.
Yeah.
Oh yeah. No, that would be good. That would be good.
If you increase the delay at line 28.
Mm-hmm. Yeah. Okay. Okay. Yeah. Look at that. So in here, it's still active with the increase of time. This is way deeper.
So even if something is suspended, the state is on.
That was a snapshot in time.
Oh yeah. So like that is a snapshot in time. What it's saying, like, I guess active and suspended does not mean the same thing. Like this is, it could, what active means in this case, like when we're referring to coroutine status is just like, is it alive? Is it done with work? Like that's kind of what that references. So I don't know. Do you guys know if there's a way to actually check if something's suspended? That's something I've never tried. I don't think that's possible. Yeah. But yeah, it's possible to have it be.
On debugs, I think you have a way to do conditional debugging, so you can actually like, hook into status like suspended.
Oh, that's
and
true.
You might have it only break or debug, but yeah, break on that break point.
Yeah. You're right. I forgot. Like it is in here. You're right. So if we go here and we just click a few more times. Oh, I don't want to go too far, but I want to just get into something else. Yeah. So you can see here it says active and it also says suspended. So it is possible.
Yeah, I think actively complete has more to do with the deferred type rather than the coroutine.
Yeah.
It's more of that on the deferment of the work. So whether the work is running or whether it's gotten to its result, rather than what's happening inside the actual work itself.
Yeah. Yes.
Yeah, deferred is a type of
It is a subtype of a job.
doing the same job.
Yeah, but like jobs have the same states. Yeah. It's a state machine. So it just is. But before, I mean, it does being on a single thread.
That's the other bit.
You can't print a status without like while it's suspended.
No, that's not possible. I will say the print is the most accurate that you're going to get, unfortunately, and that's a limitation. You can't even tell if it's suspended or not because it can't do that. So that's fun. Another fun observation is out of all the coroutines that are here, you can see that only one is running in this parent-child hierarchy. So that's kind of fun. And then everything else, like in the case of coroutine 5, which is task 3, it's like, well, we created it, but we haven't started the work yet. That's what that means. And then everything else that is currently running is just suspended. It's just waiting its turn. So really fun stuff. Okay. Wow. I did not, like, my brain is working right now. No, this is really fun. I'm really glad we're doing this. Yeah, we will be, how far is Turtles from here?
It's not too far. It's like a 5-minute walk.
Oh, say no more. Okay. Let's kill all this because my computer is really choking right now, and I just don't think it can handle all that. We might come back to it, we might not, but yeah, my head is like, you've done enough thinking today. Okay, let's go back to the presenter slides. Huh. Okay, that's one. Go back here. All right. That was wow, we did so much there. There was a lot of insight there, and the cool part is I still have those notes, so I hope I can publish some of these extra notes. I don't know how yet. It'll probably go on Patreon first. I'll explain that later. I have this growing stack of like papers, and like it's starting to get scary, so I started putting it on there as a way to save everything. But yeah, I think I will come out with a follow-up at some point in the future about all this really fun exploration. Like, oh my gosh. Okay, so now we're ready for coroutine context. Remember how we talked about how all the coroutines that we've used, everything we've used to launch has no arguments. You can put in arguments. We talked a little bit about jobs, but we're staying away from that today. Yeah, okay, so coroutine context, it designates what task executes on a thread or a thread pool. That image we had before was gone, where we had like all these different threads, but there's, in computers, there's different kinds of thread pools that you can use. For example, you have like the IO, which is input output, and then you also have in coroutine world default, which is more for CPU related work. And we'll talk about those differences in a little bit. Okay, so this is really cool. This is one of the things you can do to achieve structured concurrency. Both the idea of scopes, which we don't really cover much in this talk, other than the basic idea that a scope kind of keeps track of everything in the hierarchy. But here's like the real mind boggle. Coroutine stuff. Where was that other one? Thank you so much. Coroutine scope is also materially the same as a coroutine context. It is kind of the same thing by definition. If you look in the actual code itself, a coroutine scope, code-wise, is an interface, I believe. You know what? Don't quote me on that. No, it's not an interface, but it's a very small class, and it holds a coroutine context, and that's quite literally it. It's kind of the same thing. That's kind of what it is. It's really confusing. And then coroutine context, like that is a whole. The deeper and you go, like you start asking these like simple questions, it starts hurting a lot. But what I would say is materially they are the same thing, but the difference is what it is intended for. So coroutine scope, the intention is kind of like the whole context of everything. And then the coroutine context itself designates what thread or thread pool a coroutine exists on. So there's a lot of, I'm getting a headache just thinking about it. But the really cool thing with coroutine context is you can feed it into, async launch. It doesn't really matter, but we have async launch, and you can put in an argument with some kind of coroutine context. For some reason, we're calling it dispatchers. That's a question I still have to, why do they call it that? I don't know. If anyone knows, let me know. That's so... I suppose you're right. Yeah. That does make sense. That's so old. I don't know. No one sees that. It's like the coffee maker thing, and no one knows how a coffee maker works. And I don't know. It was. I don't know. I'm just gonna. So you can use a dispatcher to indicate what coroutine context you use. And so usually it's like dispatchers.io, dispatchers default, which is CPU, so on and so forth. You feed that in, and that tells you what thread of work you're on. This entire time we've been doing this on the main thread. We have coroutine scope, launching with context. These are 3 ways that you can change the context of a coroutine. Coroutine scope, let's see, we're not going to get too much into that because we're a little low on time. And we talked about launch context. So that's like you can use any standard coroutine builder and feed the dispatcher directly into it. But another cool thing you can do is use with context. So if you're within some kind of coroutine, you don't have to launch a new one altogether. You can simply change the context of the thread you're operating on within the same coroutine with context. So that's really cool. I'll show you what I mean. I think we're done doing mind-boggling stuff. It's all observation. We can like relax now. And this is actually a lot more Android-based too, because if you try to do this code lab and try to play with like thread.main, you cannot, because thread.main is only available for frameworks that have UIs like Android, Swing, I don't know what else, but anything with UI. So the rest of the context here is going to be Android related. And we talked about this view model scope. That is like what folks should be using in Android, especially in view models. That's where you should be launching that main coroutine from. And the cool thing is it takes care of itself too, because there's some complicated stuff about disposals and you just don't have to worry about anything. That's the TLDR. We do have a scope in this case where we have the coroutine scope, and you'll see here, I should have fixed some of this because there's a lot of implications here, but coroutine context provider is just an interface class that you can use to easily test, but it stores all these because when it comes to testing in Java, or sorry, not Java, Android, it gets kind of weird and you have to use unconfined and it becomes a mess. So you save everything to your own interface. You can just change it out in testing and it doesn't make things so complicated, because as we've learned today, anytime you run in any different environment, even in testing, coroutines are going to act different. So you just kind of take it out of the equation and put it in as as an injected dependency. That's just the best way to handle it. So that's kind of more for Android folks. But yeah, we're going to get into viewmodelscope.launch. We have scope.launch. I'm not sure if there was, yeah, what's up?
Can you explain what the purpose of using launch on the scope versus launch by itself?
Launch on the scope versus launch by itself.
The previous example,
Yes.
you're using just launch.
Yes. Yeah, so we talked about how like scope before was kind of like related to what we can all keep track of. The cool thing, oh man, now I feel like I'm gonna like start confusing it. I'm a little scared I'm gonna answer this wrong. I know you can cancel. I want to say you should be able to cancel the scope itself. I think it just separates out. You know what? I'm scared to answer this one because I'm worried I'm just going to get it wrong. But I believe at least like in this case, like in this particular case, the main difference here is you're creating a whole new scope, but you're starting it on a different thread itself. So functionally, it goes to context pool, well, dispatchers.default, but that doesn't actually answer your question. Just in this case, it's to change the context. Oh, do you have the answer for that? Yeah.
I think I know where you're going with this. Really the only difference is lifecycle awareness. So it's very much so that if you launch the scope, launch the coroutine on a scope that you create, you have to yourself build the guardrails around it to make it lifecycle aware, whereas using a view model scope that's built in. So
it will do that.
Yeah, I think it will just, the scope will become like a child of view model scope. So I think if you cancel view model scope, it will cancel it.
Yeah,
that would happen, yes.
That happens automatically because you've defined your own scope using a builder. So
I think that's just to make it run on a different thread.
they're going to be on
All
the same
these things are
dispatcher.
true.
And the crux of the question, I think I was leading to, like, when would you use one over the other? Right?
Oh, when do you want to choose one? Well, in that case, that would be the appropriate answer. But I would say, generally speaking, if you want your things to be managed by the lifecycle of the Android view model scopes, because like the view model itself, like it kind of does it, but yeah, I think that's the part that you kind of have to be a little careful about, because I think in here,
I think generally you would provide a dispatcher with a view model scope launch if you want to.
I think the main lesson that I wanted to like introduce with this is one of the benefits of using scope.launch is if you need to manage the lifecycle yourself, like everything launched within there, you can just cancel the scope and it'll clean up everything inside of it.
You could, yeah.
Yeah, like I think in this specific example, actually, if you did instead of scope dot launch, we just did this context of the default dispatcher, because we're not using that launch job anyway.
Yeah. But yeah, this is also a great question, because the thing is, like, this answer would be different if it was like not Android and it was just scope.launch versus scope.launch too. And so yes, in the context of Android, you want to work with view model scope because it handles the life cycle for you. You don't have to worry about it. I would say if you were to do something like this, you got to really know what you're doing. I would write a lot of testing around it, like a lot of permutations, just to make sure you didn't get anything wrong. Because if you got something wrong, well, we don't talk about it in this talk, but there's no coroutine exception handler here. It's going to get swallowed up and you're not going to know what happens. Yeah.
Just to finish that, I think a practical example of whether or not you use lifecycle aware scopes would be that if you have that do heavy work method and you didn't manage the lifecycle yourself under your own scope, if the view model is to be cleaned up, or if whatever context you're in is to be cleaned up, that work would continue to happen in the background. So you'd be wasting
that too. Yeah.
resources.
If it's like forever
Battery life.
running for whatever reason.
Right.
Yeah. So it is dangerous to write your own scopes. And for first timers, if it's hard for you to follow along, this is challenging even for intermediate and seniors. So this is, yeah, I would say generally, like in my own programming, I generally stay away from working with individual scopes. Unless it's like so far away, especially from any kind of UI, like really far away, and I don't care about it. And if it fails, that's like, I'm not saying that I pretend to know how to manage it myself, because I don't try to. Yeah, trying to handle scope is weird. And then it gets even weirder. I'm like not even this far yet in my research. Like I touched on it and it gave me a headache, so I'm going to come back to it. But so the thing about coroutine context is that it is a composite design pattern, and that gets so weird because so far we've talked about async. I did not think we were going to get this deep into it today, but we have async, and I said before we can put in a context, so we could put in dispatchers .job, or sorry, IO. Starting, my own brain's breaking a little bit, and you can even add a job in here. You can also add in the context. You can even switch the order of this, but the behavior becomes different when you start trying to cancel stuff. Like one version is not cancelable, and I think it's scope. So that's something that I'm currently looking into. The whole thing's just a total mind boggle, and that is why what I tell everyone starting out is to just stick with this, because we can understand this very easily, and we're not worrying about life cycles of anything because time is hard to manage. But we can manage where we're at, so we can do that. Okay, what is next after this? Oh yeah, quick note. View model scope, the implication is the default is set to main. I want to say that's correct. It's been long. I didn't check that portion of the code. And I've been kind of like very, very stuck in the IntelliJ IDE world for a while. So, okay, let's go into this. We have view model scope.launch, scope.launch. We're doing some heavy work here. And in this case, we're implying that we know what we're doing. That's why we're doing the scope.launch. Then we have this heavy work that we're doing within. We're doing another scope launch in here. What occurs? Task 1, task 2. So we have a for loop, and we're counting out 5 tasks. Fine. We keep going. We change that scope.launch to dispatchers. Okay, so here's that other bit. Remember how we talked about how everything was living on the main thread? When we did that scope.launch, you'll see in the logging here that we're changing to dispatch, default dispatcher worker. You see like 1 and 2. It is possible for this work to go up to, I think, whatever amount of CPU cores you have on your device. And then for IO, it's like up to 64. So you only want to use really, really heavy work with like defaults, dispatchers, and you want to use like networking or other input output like text, writing, documents, whatever. That would be like IO. And like I said before, you can't control how many threads are used. Coroutines just decides for you. So you see, I ran it twice here, and the result was a little different. Like that's kind of just what happens sometimes. So for generally speaking, it's something you don't have to really worry about. I don't think it's ever something I've had to worry about, like in terms of like concurrency debugging. It's usually just something I did wrong with some kind of life cycle management. That is usually where a lot of that pain comes from. Okay, in this case, I changed it to dispatchers IO. The other fun thing is that dispatchers IO will like kind of by default run onto the default stuff first. So it'll just make use of that, and then it'll only use those extra threads if it needs it. So I know we're getting like this talk ended up being a lot longer than I thought it was going to be. And then of course we go to main, everything changes to main. That's fine. And then here's another quick part for Android folks, because we're talking about, so really, really quick for those that don't do Android. In the Android world, we have one UI thread. We cannot mess with that, or the app, or like just nothing works. So don't mess with it. It always has to keep running. And then all other work must be on some background threads. That's usually how we do things. Anytime we like have actions to like touch, or maybe like change the UI, all of that is done on the thread. So anytime we interact with the view, that has to be done there, but we cannot touch a view in a background thread. So that's what this is about. We have like a view state value. That is an Android component, the view state itself. And we try to update with some kind of class, and we put in some data, but this is actually going to give us some kind of crash, because it says we cannot invoke set value on a background thread, because that is currently what's happening. We ran the scope.launch, and earlier we said it was a default dispatcher. We never brought it back to the UI. So you use with context, and it doesn't actually launch a new coroutine. It just changes the thread. You're still in the same coroutine. And that's just kind of the note for Android folks. Okay, so we did it. We got through it. Yay. Thank you so much, guys, for this is like really, really great. I do have written parts of this lab on Medium. There's parts 1, 2, and 3. And I guess now there's going to have to be a 4th part or something. Some other things. I don't know, like I didn't know how to like put everything together that I've already been doing just kind of with the community and stuff. So I created an LLC, and that's just an easy way to put everything into the same bank account. It makes it easier. So another thing that I'm doing in the near future is I'm partnering with Pilsen Arts and Community Center, and I'm going to give artists a workshop for like how to build their own HTML website, so that they can like have a portfolio for their artwork, help their businesses. So I thought that was just like kind of a fun thing to share, and I hope like I can share a lot more about that in the near future. I did mention that I put a lot of my research on Patreon, and I post every Tuesday or so, and that's kind of what I've been doing lately. Just, it's like I said, I have a whole bunch of papers sitting precariously in my room, and it's making me really nervous. So I'm finally just putting this all out. And yeah, it's just ongoing. And then I do have a book giveaway. I don't know if there was ever, oh yeah, I guess we could do that now. So if I asked O'Reilly to send me a book, but I got to wait several days for it. So we can do like a quick raffle or something. And then also, if you want to follow me on socials, I have socials. I don't know if there's anything else. I think that was kind of it. Yeah, that was it. Thanks for holding on with me. Yes. Yes, yes. Are there any final questions? I don't want to hold people because I know it's getting up there and stuff, but oh, there was a, oh no, there was just that one question, which I will answer in the future with a visual. Yes. Jed IKV, please be sure to, I don't know, like follow me on one of the socials so I can make sure to like send you, or maybe I could put a link in here too so you could just check the comments later on. Whatever works. But yes, the best way to visualize the suspended function, it's just pausing. Like it's just like pause and waiting. And like I said, it's kind of like dancing. You know, you're paused and then you just ask if someone else can cut in. So that's a good way to think about it. Okay, I think that's everything. And thank you so much to everyone on YouTube for hanging on and watching. And I really, really appreciate the love online and in person too. Thank you all for coming. I'm going to stop the live stream. Thank you so much. Yeah, I think that's everything. I would say I'm going to leave a few comments on here on how to apply for, like, you can do like a YouTube talk online. That works great. Or you could apply in person for a CKUG talk. Also, I'll put my information for Patreon if you wanted to look into more of like the research that I do, because there's just a lot of sheets of paper. I think that's kind of it. And then, of course, I'll post the slides online and on the meetup as well. So thank you so much. It was nice for y'all. Have a good night. And then for the rest of us, I think, how do we end the stream? How do we do it?
Pull the window and then end the stream.
You're right. It's been a while since I've done this. I'm going to remove this. All right. Have a good night, y'all. End stream. You're right. That's